Present value. Present value. Okay, so let's think about this. If I have someone paid $39.55 for an item, including tax, how much was the item before the tax? So they paid $13.55, but we need to know how much it was with tax. Okay, so we know that to figure out the price with tax, we multiply by 1.13. So clearly to find out the initial price, we need to divide by 1.113. So it'll be something like this. Price times 1.113 equals $39.55. Divide both sides by 1.113. And it was exactly $35 before tax. Cool. Now for the next example, you're going to be sorry that you were not in class, because I usually do this. And I say, okay, without using a calculator, try to figure this out. What is the most expensive item you can buy with $100? So basically find out the price before is 13% tax. So what would it be? Can you buy $90 worth of a product? Or is tax going to be over 100? Can you buy $99? Definitely not. Can you buy $50? For sure. So what's the most you can do? And to make things interesting, I usually pull out something like this. And I say, whoever gets closest to it will get my congratulations. I'm not giving that out. All right, so it actually turns out to be 88.49 when you divide it by 1.13. So 88.50 pretty much. Okay, let's move on. Interest rates. So hopefully you got a chance to check your interest rate. Your checking account is paying you close to nothing, like 0.001. Your high savings account somewhere is like 0.1, which is ridiculous. But it's what the economy is right now. I have an account that pays me a little over 1%. But if you notice, credit cards, they will charge you 20% per year. So they'll give us less than 100% and they'll charge us 20% if we don't pay the credit card back. So be careful with those things are. So now when we talk about investing money at 4%, 5%, 6%, that's not quite realistic for banking accounts. Now, if you're investing your money in the market, then that kind of goes up and down, and you will get some larger values, but they're not guaranteed to stay the same way all the time. This is just mortgages, and notice that in 1980 something, mortgages reached above 20%. So when we talk about bigger percentages, it may not be accurate for right now the way the economy is, but they have appeared in the past, so there's some truth to it. I like to show how, like, at the beginning you put a little bit of money and it grows into a bigger chunk of money, right? But we're doing this a single deposit. This is what we call a lump sum. So put the money, and apologize for I'm about to sing. Let it grow, and just pick it up at the end. So if you invested a little money, you pick up more money. If you borrowed a little money, you will pay back more money. But there's nothing happening in the middle. There's an example from last class, so I'll let you check it out if you want to stop it. But so far we're saying, okay, if I put this money, how much will I get? But I want to find out, okay, if I need this much money, how much do I need to invest now in order for me to get it? Like if I want to buy something in the future, how much do I put now so the interest will make it go up to this much and I'll have it to plan for my future? That's a good idea. So how do we figure out a formula for it? It's pretty easy. We just got to isolate per P, which means that we got to get rid of that bracket and bring it over to the other side. Or divide both sides by bracket 1 plus I to the power of n. And as you can see, that's the formula right there. But remember that we learned exponent laws, and the negative exponent makes the bottom go to the top. So here's the actual formula. P is equal to A bracket 1 plus I to the power of negative n. So one very, very small change, and that's negative n. And here's a sheet that you can kind of complete little by little, where you're going to have all the 4 formulas plus the 5th formula for this unit. There's only like 5 formulas. This formula will always be given to you, and that's what they're there. And just one example for today. So let's say, because it's pretty much the same as last class. If you need to get $1,700 in order to be able to afford, and we make this up in class, this is the last one I got, a MacBook Pro, you can invest money now at 4.7%/A, that means per year, compounded bi-weekly. How much money should you deposit today in order to have the necessary funds in 4 years? So we're just going to put one chunk of money and let it grow into 1,700. So it should be smaller than 1,700. And okay, so the I, what is the I? It's 4.7% compounded bi-weekly. So that's 0.047 divided by 26, right? And the N, 4 years, bi-weekly. So there are 26 periods per year, so multiply by 4 is 104. So the formula is going to be 1700 bracket 1 plus 0.047 divided by 26 to the power of negative 104. If you forget that negative, you're going to get a bigger number, and then you know that that's wrong. When you plug that in, you should get 1408.88, and that would be enough that if you plug in an account that pays 4.7% compounded bi-weekly for 4 years, it will grow to 1700.